first I'd like to make a suggestion that you have a printout of the steps for balancing redox reactions handy so you can follow through. First step is to determine oxidation numbers of the elements. Bromine, an element by itself, uncharged, is going to have an oxidation number of 0. Same is true of the titanium, oxidation number of 0. And again, remember I put these values inside circles so that reminds myself, that helps me remember that these are not charges, but these are oxidation numbers. Monatomic ions have oxidation numbers equal to their charge. So bromine is -1, titanium 4 is +4. Okay, now we're going to connect up these elements. Bromine is being reduced. It's going from an oxidation number of 0 to an oxidation number of -1. Titanium is being oxidized. It's going from 0 to +1. So this oxidation number is becoming more positive. Oxidation. Bromine, oxidation number is becoming less positive. Reduction. Next, we want to balance species oxidized and reduced. Okay, note that bromine has a subscript 2. You gotta be very careful of these subscripts. We have 2 bromine atoms. Now, before we worry about numbers of electrons, we want to balance the bromine atoms. So we have 2 bromine atoms on each side. Again, this is before worrying about numbers of electrons. 1 titanium atom, 1 titanium atom, we're good. Now that those elements that are changing oxidation number are balanced, we can worry about electrons. Again, the rule is 1 electron per unit change in oxidation number. So titanium going from 0 to +4, that involves 4 electrons. When we look at bromine, we see there's 2 bromine atoms. Each is going from 0 to -1. So this reduction is going to involve 1 electron per atom bromine. So we have 2 atoms of bromine, 2 electrons are going to be involved in total. This means, as written, the bromine atoms are going to require 2 electrons to be accepted, and the titanium atom is giving off 4 electrons. We need to match electrons lost to electrons gained, which means we're going to have to double the amount of bromine that's involved in the reaction. Okay, so note here that the 2 needs to change to a 4. The coefficient associated with titanium remains as 1. And now you can see we're done, we're balanced. Let's check our balance. 4 bromine atoms, 4 bromines. 1 titanium, 1 titanium. Now let's check the charge. So we have 2 bromines, each of which has a charge of 0. It's a neutral molecule. We also have a titanium, which is also neutral. On the product side, we have 4 bromines, each of which is -1, and we have 1 titanium that's a +4. So each side of the equation has a net charge of 0. We're balanced for mass, we're balanced for charge, we're done. Now let's look at the second redox reaction. Aluminum as an element has an oxidation number of 0. Monatomic ion has an oxidation number equal to its net charge, and +1. So let's connect up those things that are changing. So here aluminum is oxidized, going from 0 to +3. That's increase in oxidation numbers, becoming more positive. This is going to be oxidation. Thallium goes from +3 to +1, a decrease in oxidation number. That's going to be reduction. Next, we balance the atoms that are changing oxidation number, but they're already balanced. We have 1 aluminum, 1 aluminum, 1 thallium, 1 thallium. Next, we worry about electrons. Aluminum is going from 0 to +3. That's a process that involves 3 electrons. Thallium is going from 3 to +1. That's 2 units change. That involves 2 electrons. Now we want to match electrons lost to electrons gained. We consider the lowest common multiple of 2 and 3. That would be 6. So we want 6 electrons lost, 6 electrons gained. So we need to double the amount of aluminum that's involved and triple the amount of thallium. And now we're balanced. Let's check our mass balance and our charge balance. 2 aluminums, 2 aluminums, 3 thalliums, 3 thalliums. Now let's check the charge. All right, we have 2 aluminums, each has a charge of 0. 3 thalliums, each has a charge of +3. So we have a net of +9 on the reactant side. On the product side, we have 2 aluminums, each is +3. We have 1 thallium, that's +1. So we have a net charge of +9 on the product side. So there's a charge balance. There's a mass balance, we're done. Again, note, the net charge on each side does not need to be 0. It's just the requirement is that the net charge is the same in the reactants as it is in the products.